today's class, let's get started with continuity. So when can you say that a function is continuous? If its left hand limit is equal to right hand limit, a function is said to be continuous. Okay, so let us take some important SAQs. So the first question is the function f defined by f of x is equal to x square if x less than or equal to 1 and x if x is greater than 1, continuous on R. So first we need to find the limit at a is equal to 1. So we will write what is the given function. Given f of x is equal to x square if x is less than or equal to 1 and x if x is greater than 1. First we will find out left hand limit. So when we are taking left hand limit, we need to choose a function where x is less than 1. So left hand limit is limit x tends to 1 minus. For left hand limit, we denote by 1 minus, and for right hand limit, we denote by 1 plus. And now we have to select the function where x is less than 1. So x is less than 1, it is x square. So this is x square. So that is equal to limit x tends to 1, it is x square. So once you have selected the function, you can remove this minus. So now you substitute x is equal to 1. So 1 square is 1. Now we need to take right hand limit. Right hand limit is limit x tends to 1 plus f of x. Now which is the function we need to choose? Where x is greater than 1. So limit x tends to 1, we need to take x. So in the place of x you substitute 1. So you got left hand limit is equal to right hand limit. Therefore limit exists. And limit f of x tends to 1 is equal to 1. Now we find f of a. F of a is f of 1, that is 1 square, which is equal to 1. Therefore, limit x tends to a, f of x equals to f of 1. Therefore, f is continuous at x is equal to 1. Hence, f is continuous on R. Take the next question. This is also very important. Is f defined by f of x equals sine 2x by x if x not equal to 0 and 1 if x is equal to 0, continuous on 0. So you need to find out if f is continuous on 0 or not. So like in the last problem, we don't have like less than or greater than symbol. Okay, we have is equal to and not equal to symbol. So how to proceed? Let us see. First you write the given function. Given f of x equals to sine 2x by x if x is not equal to 0 and 1 if x is equal to 0. Now you take a is equal to 0. So limit x tends to 0, f of x is equal to limit x tends to 0, sine 2x by x we will take first. Now we use the limits concept here. We know that limit x tends to 0, sine x by x is equal to 1. Now over here you have 2x. In the denominator also you should have 2x. Then only you can apply this standard limit. So what do? We multiply and divide by 2. So I am dividing here by 2, multiplying by 2. So that is 2 into 1, which is equal to 2. Now f of a is equal to f of 0. That is equal to 1. Therefore, limit x tends to a, f of x is not equal to f of 0. Therefore, f is discontinuous at x is equal to 0. So after solving this sine 2x by x, you got 2. But over here it says 1. So because 2 is not equal to 1, the function is discontinuous. Now take this question. We need to check the continuity of the following function at 2. So the function is given as 1 by 2 into x square minus 4 if x lies between 0 and 2. And it is 0 if x equals to 2. 2 minus 8x power minus 3 if x is greater than 2. So first we will see at a is equal to 2. What is the left hand limit? So left hand limit is limit x tends to a minus f of x. So over here a is 2. So limit x tends to 2 minus f of x. Now we need to select the left hand limit for this function. So where you have x less than 2, we need to take that function as left hand limit. So limit x tends to 2. We need over here you have x less than 2. So we need to take this function. So that is 1 by 2 into x square minus 4. Now you substitute. So you will get 1 by 2 into 2 square minus 4. That is 1 by 2 into 4 minus 4, which is equal to 0. So you got left hand limit as 0. Now let us find out right hand limit. So right hand limit is limit x tends to a plus f of x. Now in the place of a you write 2. So limit x tends to 2 plus f of x. Now where x is greater than 2, we need to take that function. So over here we can simply write x tends to 2, and in the place of f of x we substitute the function. That is 2 minus 8x power minus 3. So that is, now you substitute it, 2 minus 8 into 2 power minus 3. So that is 2 minus 8 into 1 by 2 cube. 2 cube is 8. 8 and 8 cancel. So 2 minus 1 is 1. So you can see left hand limit is not equal to right hand limit. Therefore, limit x tends to 2 f of x does not exist. Limit does not exist. Therefore, f is discontinuous at 2. Now take the next question. Check the continuity of f given by f of x is equal to x square minus 9 by x square minus 2x minus 3 if x lies in between 0 and 5 and x is not equal to 3. And the value is 1.5 if x is equal to 3. So what do? First we write the given function. Given f of x is equal to x square minus 9 by x square minus 2x minus 3 if 0 less than x less than 5 and x not equal to 3. Then 1.5 if x is equal to 3. Now we take limit x tends to a f of x. So in the place of a we take 3 because over here it is given at the point 3. So x tends to 3 f of x. Now we take the first function, that is limit extends to 3, x square minus 9 by x square minus 2x minus 3. So directly if we substitute, we are getting 0 by 0, that is indeterminate form. So we have to apply the concepts of limits. So we have to factorize numerator and denominator. So x square minus 9, you can write x plus 3 into x minus 3. And this denominator, if you factorize, you will get x minus 3 into x plus 1. So these two get cancelled. You get limit x tends to 3, x plus 3 by x plus 1. Now you can substitute the value 3 plus 3 by 3 plus 1. That is 6 by 4. 2 twos are 2 threes are. So that is 3 by 2, which is equal to 1.5. So you got the same answer as when it is x is equal to 3. So that's why we can say that it is continuous. So now you say, like, now f of a is equal to f of 3. That is 1.5. So therefore, limit extends to 3, f of x is equal to f of 3. Therefore, f is continuous at x is equal to 3. So take the next question. Find real constants a and b so that the function is continuous on R. So here 4 different values are given based on the intervals. So like it is sin x if x is less than or equal to 0, x square plus a if x lies between 0 and 1, bx plus 3 if x lies in between 1 and 3, minus 3 if x is greater than 3. But over here, it is not given continuous on 1 or continuous on 3. It is given continuous on R, which means we have to find all the points. Like we have to find that x is equal to 0 and also we have to find that x is equal to 3. So first let us write down the given function. Given f of x is equal to sin x if x less than or equal to 0, x square plus a if 0 less than x less than 1, bx plus 3 if 1 less than or equal to x less than or equal to 3, and minus 3 if x is greater than 3. Now since f is continuous on R, so you can say f is continuous on 0 and 3. Now let us check at x is equal to 0. So at x is equal to 0, what is left hand limit? Left hand limit is limit extends to a minus f of x. Now in the place of a we write 0 because a is equal to 0 here. So extends to 0 minus. Now look at the function. When is it given x less than 0? So in the first value it is given x is less than 0. That is sin x. So we can write x tends to 0 and in the place of f of x we will write sin x. Because sin x is the value when x is less than or equal to 0. So that is sin 0 which is equal to 0. Now we will find right hand limit. Right hand limit is limit extends to a plus f of x. So that is limit extends to 0 plus f of x. Now when is it given x greater than 0? So x greater than 0 or 0 less than x, both are one and the same. So it is, the function is x square plus a. So limit extends to 0, x square plus a. So that is equal to 0 square plus a, which is equal to 0. So since f is continuous at 0, it is given that it is continuous at 0. That means left hand limit is equal to right hand limit. Therefore, a is equal to 0. You got the value of a here. Now the same way we will do it for x is equal to 3. So over here we first find left hand limit. Left hand limit is limit extends to a minus f of x. So that is limit extends to 3 minus. In the place of f of x, we should choose a function where x is less than 3. So look at the question, when is x less than 3? So the function is bx plus 3. So that is, now substitute x is equal to 3. So we get 3b plus 3. Now the same way RHL is right hand limit, x tends to a plus f of x. So that is limit extends to 3 plus, when is x greater than 3, the value is minus 3. So directly I can write minus 3 because there is no x term here to substitute 3. Now again, since f is continuous at 3, so again we can write left hand limit is equal to right hand limit. So 3b plus 3 is equal to minus 3. 3b is equal to minus 6. B is equal to minus 2. Finally, we need to conclude. Therefore, A equals 0, B equals minus 2. So take the next question. This question is very, very important. Show that f of x equals cos ax minus cos bx by x square if x not equal to 0, and half of b square minus a square if x is equal to 0. We need to show that this function is continuous at a, at 0, where a and b are real constants. Okay, so first we will write what is given to us. Given f of x equals cos ax minus cos bx by x square if x is not equal to 0, and half of b square minus a square if x is equal to 0. So for this we use cos c minus cos d formula. So first let me give you what is cos c minus cos d from transformations. It is minus 2 sine c plus d by 2 sine c minus d by 2. This is the formula we are going to use now. So first we take, so that is equal to limit extends to 0. We take cos ax minus cos bx by x square. So directly if I substitute x is equal to 0, you will get 0 by 0 form. That is indeterminate form. So we cannot do direct substitution. That's why we are applying cos c minus cos d formula. So that is limit extends to 0 minus 2 sine a plus ax plus bx by 2 sine ax minus bx by 2 by x square. So that is equal to limit extends to 0. Minus 2 we will take out because minus 2 is a constant. So that is minus 2. Now from both the brackets we will take x common. So we get a plus b by 2 into x sine a minus b by 2 into x. Over here we write by x. Over here we write by x. So now you see we have to apply the standard limit here. So we know that limit extends to 0, sin x by x is equal to 1. So here in the place of x you have a plus b by 2 into x. So in the denominator also you should have a plus b by 2 into x. But we don't have that part in the denominator. So we will multiply and divide by a plus b by 2. So multiplying and dividing with a plus b by 2 with the first term and a minus b by 2 with the second term. So that is minus 2, limit extends to 0, sine a plus b by 2 into x by a plus b by 2 into x. Now the same way, limit extends to 0, sine a minus b by 2 into x by a minus b by 2 into x. Over here we have divided with that term. Now we have to multiply also. So a plus b by 2 into a minus b by 2. Now this part will become 1 and this part will become 1. So that is minus 2 into 1 into 1, and this is a square minus b square by 4. Now 2 ones are 2 twos are. That is minus of a square minus b square by 2, which is equal to b square minus a square by 2. Now if you look at the question, you have half of a square minus, like half of b square minus a square if x is equal to 0. So here we proved it for x not equal to 0. Now we will prove it for x is equal to 0. So therefore, limit extends to 0 f of x is equal to f of 0. Therefore, f is continuous at x is equal to 0.